continuity and one-side limits. In the previous lectures, we have learned how to find the limit graphically. So for example, if you have a function, this is the xy coordinates. This is the function f, right? For example, this is the function f. And here is x equals c. This is the x, this is the y, right? We say, so here is the corresponding point, right? And the values here, if this is the y equals f of x, right, then this value is L, for example. So we know that when x, what is this one? Just the limit x approaches c of this f of x. This one would be equal to L, right? And we know that when we talk about x approaches c, that means x approaches c from the left side of c and from the right side of c, right? So x approaches c from the left side of c, that means x is less than c, but very close to c, right? And then you have the corresponding points on the curve will go this way, okay? And x approaches c from the right side of c, that means x is greater than c, right? Then the corresponding points on the curve will be this one. So you can see that both blue arrows will point to this point. This point has the value L, so this limit is equal to L, right? Okay, so here is the things we know, two things, right? The left blue arrow have some tendency, and the right blue arrow also have some tendency, right? So here they meet at the same point, then we say this limit is equal to the values of that point. So now let's look at, so we want to know, we want to give some names for the left arrow, the tendency for the left arrow, and give some names for the tendency of the right blue arrow, okay? Okay, so the first thing is the x approaches c, right? That means two things, right? We know x approaches c minus. It means x approaches c from the left side of c, or x is less than c. And the tendency for this blue arrow, okay, for this blue arrow, which is called which it can be written as the limit of this function f of x when x approaches c minus. We give a name which is called the left-hand limit. Which is the tendency of the left blue arrow. We also know it also means x approaches c plus. So x approaches c plus, that means x is greater than c but very close to c. Then the corresponding blue arrow is this one, right? The tendency for this right side blue arrow, which is denoted by the limit x approaches c plus of f of x. This is called the right-hand limit or right side limit. Okay, both are called one-side limits. So from this graph, we know that if the left side limit and the right side limit or right-hand limit meet at the same point, have the same tendency, then the limit is equal to L, right? So this one gives you a very important theorem. Which says the limit x approaches c of function f of x equals L if and only if the right side limit or the left side limit is equal to the right side limit. Both have the same tendency, L. So in other words, if the right side limit is not equal to the left side limit is not equal to the right side limit, then this limit does not exist. Does not exist. Okay, so this gives you a way to identify if the limit of certain function exists or not. You need to check the one-side limits for this function. So here is an example. So let's look at this function h of t, which is equal to 0 if t is less than 0, is equal to 1 if t is greater than equal to 0. So this is called the step function. It's a very important function in engineering. It's like a switch, right? Less than 0 is 0, then greater than equal to 0, then it's equal to 1, opens, okay? So the graph for this function is this one. So less than 0 is equal to 0. So this is less than 0 equal to 0. And when at 0, which is a circle, greater than equal to 0. So this is t, right? This is the h. Greater than equal to 0 equals 1. So at 0 equals, this is a solid point, this is a 1. Then horizontal line. So from the graph, you can see that the limit x, sorry, here's not x, here's t, variable is t. T approaches 0 plus of h of t. So let's look at approaches 0 plus. So that means greater than 0. This is 0, right? This is the 0. So which would be this way. T approaches 0 plus. So the points under the curve would be here. And you can see the tendency for this blue arrow, which is this point. This point has the value 1. So it's equal to 1. Now let's look at the limit t approaches 0 minus. And the x values, t approaches 0 minus is here, right? Approaches 0, less than 0, but very close to 0. Then the points under the curve will also be here. They will be coincide, right? So the blue arrow has the tendency, which is this heart of the circle, will not be here, okay? It's the heart of the circle here, which is 0. So you can see they are not equal, so we can get to the conclusion that the limit t approaches 0 of this h of t does not exist.